Hi everybody. In this lesson, we'll be showing you how to put together a parallel circuit that does not require any soldering that you can make with the materials found in your kit. And this is the parallel circuit that we'll be creating. You can see here there's a push button switch. This looks a little different than the switch you might have, but it works the same way. The switch has two leads coming off of it. And we have three LEDs here stacked in parallel, where they're sharing the negative side and they're sharing the positive side. This way, in parallel, the circuit ensures that if one of the light bulbs go out, the rest don't go out. And then we have our power supply, which is our AA battery pack that has leads coming off of it. All right, now in this lesson, we're going to show you the circuit components, teach you some things about electricity, and help you to put this together on your own time if you need to. And obviously, since it's a recording, if the video is moving too fast, just pause and rewind. All right, and I'll also be showing you a few additional tips and techniques that could help you out depending on some of the tools that you might have at your disposal or not have. All right, so the first thing we're going to do is we're going to take a look at the LEDs themselves. So you'll be taking out these LEDs from your kit. If for some reason you didn't have the LED, you have an incandescent version with the filament inside, that's fine. Both will work the same way. And you'll notice that these have been cut out of a much larger string of holiday lights. And so what I want you to do first is to take this string apart. Take apart the three different wires that come together. And just unbraid this whole thing, untwist this whole thing, so that what you're left with in front of you will be one or two pieces of this plain wire with nothing on it. And your piece of wire with the LED lights on it, which right now the LED lights are all connected end to end, one to the next, one to the next. We would call something like this, where the lights are connected one to the next, one to the next. This is the lights being wired together in a series, right? They're in a series with each other. And that's how they work when they plug into the wall, right? But since we're not plugging these into the wall with 110 volts, we're going to be cutting these up and hooking them up to a AA battery pack. We're not going to be able to keep these in series because there actually won't be enough voltage to make it from through one light bulb and then use the remaining amount of electricity to get to the next one and to the next one. These are only 1 to 2 volt LEDs. And so we're going to need to create a parallel circuit, and that's what's going to allow us to have the LEDs share the electricity at the same time, which is super cool. And at any time after this lesson is done, you should be able to take a bunch of holiday lights from anywhere yourself and be able to convert them into a gift for somebody or into a purposeful, useful item for yourself, as long as you can get your hands on a AA battery pack. Now, if you have one of these tools available, this wire stripper, this is super helpful. If you do not have a wire stripper available, the way these work is you can cut something out inside the tool here with the cutter. We can also use the tool for stripping wire. Put the end of the wire into the jaws of the tool, and with one hand, you don't have to pull on this at the same time, with just one hand, right, we can squeeze like that, and you can see that it's already removed the insulator from the conductor. So the insulation is the whatever color coded wire you have. Doesn't matter what the color coding is on the wire. It's just rubber that's there to insulate. And then we have the copper, which is our conductor inside. And before I even remove something like this, I always like to twist it up a little bit so that the wires are not all poking out all over the place. All right, so first I want you to take the LEDs that are that are connected in series like this, and we're going to cut them, and we're going to cut them, separate them. So we're going to cut right in the middle of two LEDs. And if you don't have wire cutter wire strippers like this tool, maybe you have something laying around the home that looks like this, where you can cut in this part of the tool, and then you can strip the coating of the wire with the proper gauge here. This is a real cheapo pair of wire strippers that just cost a few dollars on Amazon. If you wanted to find something like this. But at the very least, if all you have access to is a pair of scissors, that's fine too. And let me grab a pair of scissors here so that we could use scissors to cut these wires in half. Always cut at the back of the scissor, right? That's the strongest part. So I've got three LEDs separated, and I'm going to take my piece of wire here, and I'm going to cut this wire down so it's about 6 inches long. It doesn't have to be exactly 6 inches, but about 6 inches long. And then what I want you to do, after you've got it down to 6 inches, is I want you to strip off approximately 1 inch and leave 1 inch of wire exposed on each end. Now, if you don't have this wire stripping tool, and you want to try to strip wire without it, let me show you another technique for that. Take another piece of the wire here. Something that you could do is you could take your scissor and you could just start to do this to it in the same location and see if you could score the coating just enough so that you could put your fingertips on it or grab it with a pair of pliers and pull off. That's one method. Another method that would be helpful, if you have your X-Acto razor, would be to take your X-Acto blade or your box cutter and push it down onto the insulative coating and start to roll these back and forth with just a little bit of pressure, just enough pressure to go through the coating and not the wire itself on the inside. A third technique that works really well, probably one of the smoothest ways to remove the wire, could be to take a lighter and just run it underneath the wire a little bit to soften it up. Pull it off that way. All right. So one of the things we want to do before we start to build this circuit is we want to actually model or try out what it would look like if we were to make a short circuit by mistake, right? And a short circuit is when you give this battery a connection on one end And without having anything in between here, the battery and the wire, to absorb or resist the flow of the electricity, if we were to just run a wire straight from one side of the battery over to the other, right, and hold them here like this, touch them to each end, this would be a short circuit, because we'd be pushing electricity out of one side of the battery and it's being pulled into the other side with nothing there to resist the flow of electricity. Resistance is anything that it's going to be using up that electricity as it flows through the circuit. And if there's nothing there to use up the electricity and it just goes out of one side of the battery into the other, that's a short circuit, and that's dangerous because, well, in this case, the worst thing that's going to happen is it's going to result in heat. You can't get shocked. You can't get electrocuted because if you're electrocuted, that means you're dead. But you will be able to generate enough heat if the short circuit sticks around, stays in that place for too long, and that heat over time would be bad because if the heat's able to continue to be generated, then what happens is the that the battery pack would need to have a battery pulled out, and the battery, in the end, could go bad if it's allowed to sit there and short for too long. Okay, and so what we're going to model now is we're going to take our piece of wire with the stripped inch off each end, and we're going to short circuit on purpose, just so you can feel what it's like if there is a short circuit, and you'll know how to recognize it. All right. So what we're going to do is hold on to the copper, the tip of our finger, and actually touch it to the plus side of the battery, and hold it there. And then we take our other hand, and we're going to touch it to the negative side of the battery, and we're going to short circuit. Now you have to have your fingers on the copper itself and touching to the top of the battery, or else you're not going to be able to feel the heat. So I do this for a couple seconds. I start to feel the tips of the battery getting warm, and it might even get too hot to touch. All right, that's a short circuit. We're going to come back to that now. When it comes to what's dangerous, what's not dangerous, when I say things could heat up or you could get shocked, I had a student one time that stacked up 16 batteries end to end to end to end to end to end, 16 of them in a row. And then they took one giant long piece of wire. Actually, they connected a bunch of different students' wires together, made one long piece of wire. And a kid at one end of the table held it to the one side of the big length of batteries, and then somebody on the other side came over and held this end to it, and they wanted to see what would happen. Well, 16 batteries in a row is a lot more powerful than just this one battery. So the heat was so intense after about 30 seconds of them holding it like that, that the cheap metal that the battery casing is made out of started to heat up and warp. And when it warped, the two different chemicals inside the battery were able to come in contact with each other and started to permanently short the circuit. So now it didn't even matter if they moved the wire out of the way. Now these batteries are having an internal reaction that we can't reverse at that point. And in fact, one of the batteries worked so much that a little bit of this metal casing opened up, and some of the battery acid leaked out, and actually looked like if you were to squeeze a lime or a lemon, and a little bit of juice were to pop out and hit this kid in the neck. And now he's wiping his neck off, and it feels like you're getting stung by a bunch of bees. And luckily, we had warm water and soap, as well as baking soda, sitting around the room for just that purpose, in case something like that were to happen, so that we could counteract the reaction. But for that reason, we would always have students wearing safety glasses in class during an activity like this. All right. But again, if you were to have two batteries in your battery pack and somehow the wires ended up touching one another like this, or if exposed wire somewhere, once the lights and switch are added, were to cross and short the circuit, you would know, because it would start to heat up the battery pack. You might be able to smell it in the air a little bit, and the heat that would be generated around these pieces of metal might be so great that it starts to warp the plastic. And again, if that happens to you, just pop one of the batteries out, and you're good. Okay. If a battery does short circuit for more than a minute, then I really think that it's worthwhile to just get rid of that battery and get a fresh one. because it may have depleted a lot of the energy inside that battery. All right, so let's talk about these batteries before we go into building the circuit. And I'm going to draw one here on my paper. We'll go over what makes some of these things work.